In 1905, a 26-year-old patent clerk in Bern published a paper that contained no experimental data, no new observations, and no complex mathematics. Just two simple postulates. The first, the laws of physics are the same in all inertial reference frames. The second, the speed of light in vacuum is constant, regardless of the motion of the source or observer. From these two statements, Albert Einstein derived consequences that seemed absurd. Moving clocks run slow. Moving objects contract in length. Mass increases with velocity. And nothing, absolutely nothing, can travel faster than light. When I first encountered these ideas as a student, I thought there must be a loophole, some way around the barrier. After decades of working with the most extreme physics humans have ever produced, I can tell you, there is no loophole. The speed of light is not merely a speed limit enforced by some cosmic authority. It is woven into the structure of space and time itself. Exceeding it is not prohibited, it is meaningless. Let me explain why. What is the speed of light? Light travels at 299,792,458 meters per second in vacuum. This number is exact. Since 1983, the meter has been defined in terms of this speed. Call it c, approximately 300 million meters per second, 1 billion kilometers per hour. Fast enough to circle Earth 7.5 times in 1 second. This speed is not special because light travels at it. Light travels at this speed because this speed is special. The same value appears in contexts having nothing to do with light. It is the speed at which gravitational waves propagate. It is the speed at which changes in electromagnetic fields travel. It is the conversion factor between space and time. Einstein did not discover that light is fast. He discovered that c is a fundamental constant of space-time itself. Light simply happens to travel at this maximum possible speed because photons have zero mass. Why can't you accelerate past c? The naive answer, because it would require infinite energy. This is correct, but incomplete. Let me show you the physics. In Newtonian mechanics, kinetic energy equals 1/2 times mass times velocity squared. Ke equals 1/2 mv squared. If you want to go faster, you add more energy. Double the velocity, quadruple the energy. Simple. In relativistic mechanics, the formula changes. Kinetic energy equals Ke equals mc squared times gamma minus 1, where gamma is the Lorentz factor. Gamma equals 1 divided square root of 1 minus v squared over c squared. At low velocities, walking, driving, flying, this formula gives nearly the same results as Newton's. The difference is negligible. At 10% of light speed, the relativistic correction is less than 1%. But as v approaches c, gamma increases without bound. At 50% of c, gamma equals 1.15. At 90% of c, gamma equals 2.29. At 99% of c, gamma equals 7.09. At 99.9% of c, gamma equals 22.4. At 99.99% of C, gamma equals 70.7. At V equals C exactly, the denominator becomes 0. Gamma becomes infinite. This means to accelerate a massive object to exactly the speed of light requires infinite energy. Not merely a lot of energy, mathematically infinite. The universe does not have infinite energy. Therefore, massive objects cannot reach C. What happens as you approach C? Particle accelerators routinely accelerate protons and electrons to 99.9999991% of light speed. We have empirical data on what happens. Consider the Large Hadron Collider. It accelerates protons to energies of 6.5 TeV, tera-electron volts. At this energy, each proton has a Lorentz factor of approximately 6,930. This means if you could somehow ride alongside that proton with a stopwatch, 1 second of your time would correspond to 6,930 seconds for a stationary observer. Time dilation is real and measurable. It also means the proton's effective mass, its resistance to further acceleration, is 6,930 times its rest mass. To accelerate it further requires enormously more energy than to accelerate it from rest. The LHC consumes approximately 200 megawatts of power. Despite this, the protons never quite reach C. They asymptotically approach it. Every additional increment of velocity costs exponentially more energy. This is not a technological limitation. This is not about building better accelerators. The mathematics of spacetime forbids massive particles from reaching C. Why does mass increase with velocity? This is actually a misleading way to describe the physics, though it was how we spoke about it in my era. The modern formulation: a particle's rest mass does not change. What changes is the relationship between force and acceleration. In Newtonian mechanics, F equals ma. Force equals mass times acceleration. Apply a constant force, get constant acceleration. In relativistic mechanics, F equals d of gamma mv over dt. Force equals the rate of change of relativistic momentum. As velocity increases, gamma increases, and the same force produces less and less acceleration. The particle does not literally gain mass, but it behaves as though it does. It becomes progressively harder to accelerate. In the limit, as v approaches c, the resistance to acceleration becomes infinite. This explains why the speed of light is a hard limit, rather than a speed limit you can push past with enough power. You are not fighting against a barrier. You are fighting against the structure of momentum itself. What about massless particles? Photons, the particles of light, have zero rest mass. They travel at exactly c, always. This seems paradoxical. If accelerating to c requires infinite energy, how do photons manage it? The answer: photons are never accelerated. They are created, traveling at c. They have no rest frame. A photon cannot slow down because there is no slower speed for a massless particle. The energy of a photon is E equals hf, where h is Planck's constant and f is frequency. Higher frequency means higher energy. But regardless of energy, all photons travel at c. This is why c is not merely the speed of light. It is the speed of massless phenomena. Gravitational waves also propagate at c. Any particle with zero rest mass travels at exactly this speed. Time dilation. Clocks really do slow down. One of the strangest consequences of special relativity. Time passes differently for objects in relative motion. If you travel at high velocity relative to me, I observe your clock running slower than mine. This is not an illusion. It is not a measurement error. Time itself passes more slowly for you. The relationship. Your time interval delta t prime relates to my time interval delta t by delta t prime equals delta t divide gamma. At gamma equals 2, 1 second of your time equals 2 seconds of mine. This has been measured directly. In 1971, physicists Joseph Haffel and Richard Keating flew atomic clocks around the world on commercial airliners. When compared to clocks that remained stationary, the traveling clocks showed exactly the time difference predicted by relativity, accounting for both velocity and gravitational effects. The difference was tiny, hundreds of nanoseconds, but consistent with theory to within experimental error. GPS satellites experience time dilation continuously. They orbit at approximately 14,000 kilometers per hour, fast by human standards, but only 0.001% of c. Nevertheless, the relativistic time correction is 7 microseconds per day. Without correcting for this, GPS positions would drift by approximately 10 kilometers per day. The system works only because engineers account for relativistic effects. Length contraction. Space also changes. Moving objects contract in the direction of motion. If you travel at high velocity, I observe your spaceship is shorter than when it was at rest. The relationship. Your length L relates to your rest length L by L prime equals L by gamma. At gamma equals 2, a 10-meter spacecraft appears to be 5 meters long to a stationary observer. This is not optical illusion. This is not perspective. Space itself contracts for moving objects. Length contraction and time dilation are related through the geometry of space-time. They are different aspects of the same underlying phenomenon, the mixing of space and time coordinates under Lorentz transformation. The relativity of simultaneity. This consequence is perhaps the most counterintuitive of all. Two events that are simultaneous in one reference frame are not simultaneous in another reference frame, moving relative to the first. Imagine two lightning bolts striking opposite ends of a train. An observer on the platform, positioned midway between the strikes, sees them simultaneously. An observer on the moving train, also midway between the strikes, sees one strike before the other. Not because the light traveled at different speeds, the light traveled at c in both cases, but because the geometry of space-time makes simultaneity relative. This has profound implications for causality. If simultaneity is relative, then the ordering of events can depend on the observer. Event A can precede event B for one observer and follow event B for another. However, and this is crucial, this reordering only occurs for events that are space-like separated. Events that are causally connected, where one could have caused the other, maintain their order for all observers. This preserves causality. Causes always precede effects. The speed of light ensures this by making it impossible for information to travel faster than c. Why C protects causality. Imagine you could send a signal faster than light, say instantaneously. You send a message from point A to point B. Point B receives it at the same moment you sent it, according to your reference frame. Now consider an observer moving at high velocity relative to you. Due to the relativity of simultaneity, this observer sees point B receive the message before you sent it. From this observer's perspective, the effect preceded the cause. Causality is violated. Now chain the argument. What if the recipient at point B replies instantaneously? Due to their motion relative to the original sender, their instantaneous reply arrives at point A before the original message was sent. The sender receives a reply to a message they have not yet sent. They could decide, based on the reply, not to send the message. But then there would be no reply. This is a logical contradiction, a paradox that cannot be resolved. The only way to prevent such paradoxes is to prohibit faster-than-light communication. And the only way to absolutely prohibit it is to make C a fundamental limit of space-time itself. This is what special relativity does. The speed of light is not enforced by a law. It is built into the structure of space-time geometry. Exceeding it would require causality violation, which is logically impossible. What about quantum entanglement? Some suggest that quantum entanglement allows faster-than-light communication. This is incorrect. Entangled particles exhibit correlations that cannot be explained by classical physics. When you measure one particle, you instantly know something about its distant partner, regardless of separation. But, and this is the key point, you cannot use entanglement to transmit information. The measurement results appear random to each observer individually. The correlations only become apparent when you compare measurements. And comparison requires classical communication, which is limited to C. This is known as the no communication theorem. It is provable from the mathematics of quantum mechanics. Entanglement does not violate relativity because it cannot be used to send signals. What about the expansion of the universe? Galaxies sufficiently far from us are receding faster than light. The most distant observable galaxies have recession velocities exceeding c. Does this violate relativity? No. The recession is not motion through space. It is expansion of space itself. The galaxies are not traveling faster than c relative to local space-time. The space between us and them is increasing. Special relativity applies to local motion, objects moving through space-time. It does not constrain the expansion of space-time itself. Light emitted from these distant galaxies is redshifted to lower frequencies as space expands during its journey. Some light, emitted from galaxies now beyond the cosmic horizon, will never reach us because intervening space is expanding too rapidly. This is cosmology, not a loophole in special relativity. E equals mc squared. Energy is mass. Einstein's most famous equation emerges directly from special relativity. The full equation is E squared equals pc squared plus mc squared squared, where E is total energy, P is momentum, m is rest mass, and c is the speed of light. For a stationary object, P equals 0, this reduces to E equals mc squared. This equation tells us mass and energy are equivalent. They are different manifestations of the same thing. The conversion factor between them is c squared. c squared is enormous, approximately 9 times 10 to the 16th in SI units. 1 kilogram of mass, if fully converted to energy, yields 9 times 10 to the 16th joules. This equals approximately 21 megatons of TNT, 1,000 times the Hiroshima bomb. This is why nuclear weapons are so powerful. They convert a small fraction of mass directly into energy. In the Trinity test, approximately 1 gram of matter was converted to energy. 1 gram out of 6 kilograms of plutonium. Less than 0.02%. And that 1 gram produced an explosion equivalent to 21,000 tons of TNT. Chemical explosives release energy by rearranging electron bonds. The mass difference is negligible, parts per billion. Nuclear reactions release energy by rearranging nuclear bonds. The mass difference is parts per thousand, millions of times larger per unit mass. E equals mc squared explains this directly. The binding energy of nuclei is millions of times greater than the binding energy of chemical bonds, and that energy appears as mass difference. What does this have to do with the speed of light limit? The same equation that limits velocity also explains nuclear energy. The Lorentz factor gamma determines both how difficult it is to accelerate an object and how much energy its mass represents. As v approaches c, gamma approaches infinity. The energy required for further acceleration approaches infinity. Simultaneously, the energy contained in the object's mass, gamma min squared, also approaches infinity. These are the same phenomenon. Mass energy equivalence and the light speed limit are two aspects of the same physics. When we designed the atomic bomb, we relied on E equals mc squared to calculate expected yields. When we analyzed the kinematics of fission products, we used relativistic mechanics. The same theory that prohibits faster than light travel enabled us to estimate the bomb's destructive power, the experimental evidence. Special relativity is one of the most precisely tested theories in physics. Every particle accelerator confirms it. The LHC, Fermilab, SLAC, all operate according to relativistic mechanics. Particles behave exactly as the theory predicts. Time dilation has been measured with atomic clocks, muon lifetimes, and satellite systems. The results match theory to many decimal places. The GPS system provides a continuous, practical confirmation. Billions of users daily rely on relativistic corrections without knowing it. Mass energy equivalence has been confirmed in countless nuclear reactions. The energy released in fission and fusion corresponds precisely to the mass deficit multiplied by c squared. No experiment has ever shown a violation of special relativity. No particle has ever been observed traveling faster than c. What about tachyons? Tachyons are hypothetical particles that travel faster than light. They appear in some theoretical frameworks. If tachyons existed, they would have imaginary rest mass. They would never travel slower than c. They would lose energy as they speed up. However, no tachyon has ever been detected. Extensive searches have found nothing. Most physicists regard them as mathematical curiosities rather than real particles. Even if tachyons existed, they could not carry information backward in time. The mathematics shows that any attempt to use them for signaling leads to paradoxes that collapse the logical consistency of the theory. Tachyons are not a loophole. They are either non-existent or incapable of violating causality. What about wormholes and warp drives? General relativity, Einstein's theory of gravity, allows for exotic space-time geometries. Wormholes could potentially connect distant points. Warp drives could theoretically compress space ahead of a ship while expanding it behind. These are mathematically possible solutions to Einstein's equations. They are not proven to be physically impossible. However, every proposed mechanism requires exotic matter with negative energy density. No such matter has ever been observed. The required quantities are astronomical, comparable to the mass of Jupiter or larger. Furthermore, most analyses suggest these geometries would be unstable, would require causality-violating initial conditions, or would destroy anything attempting to use them. These remain speculative. They are not established physics. And even if possible, they would not violate the local speed limit. They would change the geometry of the path, not permit faster than light travel through normal space-time. Why does this matter? The speed of light limit constrains what is physically possible. It bounds the rate of information transfer, the reach of causality, the geometry of the universe. Without this limit, causality would not exist. Effects could precede causes. Logical paradoxes would be possible. The very concept of time ordering would break down. The universe we live in, the one where physics works, where logic holds, where past leads to future, requires this limit. I spent my career working with the most powerful phenomena humans have ever harnessed. Nuclear fission, the strong force. Conditions hotter than the centers of stars. None of it escaped the constraints of special relativity. The same theory that limits our travel also enabled us to understand nuclear energy. It is all connected. The speed of light is not a barrier we have failed to overcome. It is the foundation that makes physics coherent. The speed of light is a wall that cannot be broken, because it is not a wall at all. It is the structure of space-time itself. You cannot exceed c, for the same reason you cannot travel north of the North Pole. The geometry does not permit it. The direction does not exist. Mass increases without limit as velocity approaches c. Time dilates. Length contracts. Energy requirements become infinite. Causality would reverse if you could go faster. This is not prohibition. This is definition. Faster than light is not forbidden. It is meaningless. Einstein understood this in 1905. Every experiment since has confirmed it. The physics is settled. We built weapons that release energy by converting mass according to E equals mc squared. We accelerate particles to 99.9999991% of c. We correct GPS satellites for time dilation. All of this works because special relativity is correct. And special relativity requires that c is the absolute maximum speed for matter, energy, and information. The speed of light is not a wall. It is the edge of the map. Beyond it, there is nothing to find, because there is no beyond.